Hello, math crew. We're going to do day 8, Introduction to Confidence Intervals right now. This is your flipped lesson. So when you come in on Thursday, tomorrow, or today if you're watching this in the morning, we will continue this lesson. This is very important to understand so that we can continue and you're not going to be behind. So make sure that you follow the whole lesson from start to finish. All right, so what does it mean when we say Poll A shows the Republican candidates with 48% plus or minus 3 percentage points? We're going to get back to that statement in a minute. This is introducing something called a confidence interval. Confidence intervals consist of a range of plausible values that act as good estimates. They're good estimates of the unknown population parameter. Now, we talked already that we do samples because sometimes we can't get to the whole population. So what we do is in our samples, we take an interval, a range from lowest to highest where we think the actual population will fall into. So that's called a confidence interval. That's what we're going to look at today. Okay, now it says, however, the interval computed from a particular sample does not necessarily include the true value of the population parameter, but in our case, it's going to. So what I'm going to teach you is that in our cases, in our scenarios, when we do a confidence interval, our population parameter will fall into it. And I will explain more in detail, I promise. Okay, so the desired level of confidence is set by the researchers, but most commonly, and for our purposes, we will always use a confidence interval of 95%, which is 2 standard deviations of the population parameter, which you've heard already before. 2 standard deviations. So we are going to go back to that bell curve. Confidence intervals, which remember, is that interval of plausible values, can be done 2 ways. So the method of calculation depends on or on the info given. Let me say it that way. On the info given. So, but depending on what the Regents question gives you, basically, is you've got to know both methods. Because you got to be able to do it both ways. So you're going to see both today. So method 1 is where you take a sample statistic and you add or subtract it from the margin of error. Now, a sample statistic, by the way, could be the mean, right? Or p-hat, which is your sample proportion, right? So they may give you a mean, they may give you a p-hat, and then they'll give you a margin error, and then you've got to find your confidence interval from there, which we will do. Method 2 is where you use your center, your center of data, your center of distribution. So in a lot of cases, it's your mean, and you add or subtract 2 standard deviations from that. So I'll put center of distribution so you understand what we mean by that, because we've looked at some of those already. Okay, so remember, for a normal curve, here's my normal curve, right? We have the mean up here. And if we are like 1 standard deviation below and above, we're here. If we're 2 below or 2 above, we're here. And that's what we're going to focus on for our confidence interval. This is confidence interval. Remember, it's a range. Just keep thinking range, okay? And so what we're saying is 90% of the data falls within this range. And remember, if we were 1 standard deviation away, it would only be 68% of the data. If it's 3 standard deviations on each side, it's 99% of the data. Okay, so flip that page. Let's go to the next. Let's actually do it. Okay, the margin of error is supposed to measure the maximum amount by which the sample results are expected to differ from those of the actual population. The margin of error is equal to half the width of the confidence interval, and you will understand what I mean when we do this problem. Most studies are based on information collected from a sample, not the entire population. A certain amount of error is bound to occur, not in the sense of calculation errors, but in the sense of sampling errors. So like, the sampling bias, all that stuff. So this is a way in which we recognize there is a margin of error, whether it be a biasness or just the way, any of the biasness, or a way in which we don't have maybe all of the parts of the population, any of those biases that we've talked about. This gives you kind of like a safety net for it. Okay, so let's go back to that first, that initial statement. Poll A shows the Republican candidates with 48% plus or minus 3 percentage points. Answer the following questions. Determine the confidence interval. Easy. We're going to take 48% and we're going to add 3% to it. And then we're going to take 48% and we're going to subtract 3% from it. Because it says plus or minus. And that is your confidence interval. 45% to 51%. Sometimes we write it as a range in which you've written it before, like that, right? Interval notation. Remember hearing that with parentheses. Okay, so real quick, does this mean that the 48% does this mean, let me try again, this mean that 48% of the population is going to vote for the candidates? No. Does it mean 48? Does it mean 51? No. Does it mean 45? No. It doesn't mean that those are going to be the numbers. It means, and this is where you've got to be specific with your wording, because the wording is the Regents' friendly piece that you want to get your credit. When they ask you to explain your interval, we say, we believe the true population, the actual population of people that vote Republican will be between 45% to 51%. So it doesn't mean that it's actually going to be 48 or actually 51 or actually 45. It's just going to be in that range. It's our safety net. Okay, so now the other way around. We're going to consider this interval here. And notice that there are brackets on these. And I did that intentionally because you're going to see there's teachers vary in how they even teach it. Some of us use parentheses, some of us use brackets. They're all acceptable. If you remember, interval range, brackets means including, and parentheses means does not. So we have all agreed that because we've seen it in so many variations in books and in websites that it's okay to do both. So don't worry about the details of that. So what is the margin of error? So the margin of error, remember, is there's like a middle number here, right? There is a middle number. There's some kind of center. So what we're going to do is we're going to find that middle number, and we're also going to find the difference from the middle to the min and the middle to the max. So I did this to find the margin of error. I took the differences. So I did 0.65 minus 0.35, and I got 0.30. There's a difference of 0.30, and I divide it by 2. And that means there is a 0.15 margin of error, okay? 0.15 margin of error. And easily what I could do is I could say, okay, if I take 0.35 and I add that margin of error, because this is my lower confidence interval, right? The lower confidence interval. And I add that margin of error, that's going to get me to the middle number, which is 0.5. And that is going to be similar to up here, that 45% that was up here, or 48% that was up here, see this, right? So that is going to be like your mid number, whatever it was, like your average, or your mean, typically your mean, or, and it's either in a percentage or people. You'll see on the back there's people. And we're going to say, we're going to add or subtract 15% to that. And that's how we get our range of values. Okay, so I took the difference, divided it by 2, that's my margin of error, and then I found the middle of those numbers, the middle of 0.35 and the middle of 0.65. Some kids like to do it this way, so I'm going to show you another way. You could add 0.35 up, and add 0.65 up, and divide by 2. Right, so that gives you your middle number between the lower and the upper. So when I ask you to write it as in margin of error form, that's it. Find your middle number and add or subtract your margin of error. Okay, do it again. Do it for 7, but you do. Go. Go, 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 go. Give you a minute. Okay, so I took the difference of 162 and 142, 20, divided by 2, and I got 10. So my margin of error was 10. Confidence interval, so I need to know my middle number between 162 and 142. So this time I'm going to add them up, divide by 2. So I got 4, and divide by 2, and I got 152. So how I'm writing this is I got 152 plus or minus 10. Okay. How to make a decision based off the interval. The margin of error can help us determine whether the results we observe are so unusual that they wouldn't happen by chance. So if a given value falls within the confidence interval, it is likely to occur. If it falls outside the confidence interval, it's not likely to occur. That's what you got to remember. Okay, I'm going to flip it so we can kind of speed it up a little bit so you're not too bored with it. Okay, now, there's another method. Remember? I told you there were 2 methods. So there's a margin of error method, and then there is using your standard deviation. Okay? So, 55 students attending the prom were randomly selected to participate in a survey about the music choice of at the prom. 60% responded that a DJ would be preferred over a band. Members of the prom committee thought that the vote would have 50% for the DJ and 50% for the band. The simulation was run 200 times, each of sample size 55, based on the premise that 60% of the students would prefer a DJ. The approximate normal simulation results are shown below. Okay, so they did one of the simulations like we did, where they just kept grabbing like samples of 55 kids, and then they asked them that question. Right, now what you see here, this is key. Like, they'll give you a question that looks just like this, and you need this information. That is key, key, key. You got the mean, which is the center of the data, right? Where the center of the data is distributed, is evenly distributed, not evenly, but it's approximate. It's kind of a real rough bell shape. And you got a standard deviation of 0.066. So use the results from the simulation. Determine a plausible interval containing the middle 95% of the data. Okay, 95% means, remember back here, I had said to you, we're using that confidence interval of 2 standard deviations, which is, ta-da, 95%. That means they want a confidence interval. So you're going to take the mean, subtract 2 standard deviations. So I'm going to do 2 times, this is Reese can't see as usual, 0.066. That's going to be my lower value for the confidence interval. And then I'm going to do 2 standard deviations above. And when I get that math and I round it to the nearest hundredth, this is going to be rounded to 0.47, and this is going to be rounded to 0.73. So my confidence interval for this data set is 0.47 to 0.73. So depending on what the Regents gives you for each question, you have to know both methods. If they give you this, you need to know the method with the 2 standard deviations. If they give you the other one with the margin of error, you have to know that. Explain what your interval means in the context of the problem. Okay, so we believe, same wording as before. The true population, same wording as before. We believe the true population proportion of people that prefer a DJ over a band falls within 0.47 to 0.73. So there's the context of the problem. The people that prefer the DJ over the band. Okay, members of the prom committee are concerned that a vote of all students attending the prom may produce a 50-50 split. Explain what statistical evidence supports this concern. Well, it's a concern because 0.50, right, 0.50 falls within our confidence level, confidence interval. Interval of 0.47 to 0.73. The actual population mean could be anywhere, or the actual population tally total could be 0.50. It falls within our confidence interval. We know the actual population is going to be in that group, in that range. So yeah, they have a concern. It could be completely split. Okay, so that is not that terrible. I had to do it over again. There was no sound the first time. Tell you my woes. Okay, so let's go to that last page. We got one more example. We're gonna make this quick. Suppose that 62 random samples based on 10 students' responses to the question, how many text messages do you send per day, resulted in the 62 sample means shown below. Also shown below is the distribution of the sample means. So here it is, there's the sample, we'll put it on a dot plot. Based on the dot plot, would you be surprised if the actual mean number of text messages, mu, sent per day for all 11th graders in the school is 91.7. So 91.7 is right there. And I would say no, because it's close to the balance. It's close to the balance, or the center of distribution, right? The center of distribution. It's close. It's getting there, right? I mean, it's skewed left. So you got to remember that that average is going to be pulled down a little bit because there's numbers on the, there's numbers down here, right? Okay, the standard deviation of the above distribution of sample mean number of text messages sent per day is 7.5. Use this and estimate for the center from part A to calculate and interpret a confidence interval. Okay. So they're telling us we're going to use 91.7 as our center, and we're going to add and subtract 2 standard deviations of 7.5. So you're going to do 91.7 plus 2 times 7.5 and 91.7 minus 2 times 7.5. And I'm going to give you this. This is 76.7 to 106.7. Okay, now it says calculate and interpret a confidence interval for an estimated population mean number of texts. So when they say interpret, here it is again. We believe the true population. I have started this every single time with these 1, 2, 3, 4, 5 words. Use these 5 words every time you explain this. The true population mean of number of text messages sent per day is between 76.7 and 106.7. Administrations are concerned that students are sending over 120 texts per day. Is this a valid concern? Does 120 fall within our range? No. So we're going to say no. They're wrong. Because, let's be specific, 120 texts is outside our bounds of confidence interval. Right? It's outside that range. Okay. One more thing to know. You guys hopefully got all that. It's not hard math. It's just understanding that you're just looking for a range of plausible values of confidence. One more thing that's key. The margin of error is a measure of variability, right? When it comes to estimating the true population. If we increase the sample size, what should happen to the margin of error? Well, if you increase the sample size, you get closer to the population. So the margin of error will decrease because you will be more accurate. The larger your sample size, closer to the population, you will have your margin of error decrease. Okay? See you all tomorrow.